We are going to solve rational inequalities. First of all, which inequalities we call rational? Those are inequalities that contain rational expressions. So let's take the easy case, x minus 1 over x plus 3, and it's less equal than 0. So, first thing what we have to do is determine critical points. Critical points are the points where the rational expression will be 0 or undefined. So let's take the x minus 1 numerator. If x minus 1 is equal 0 and x is equal 1, so this is critical point. Okay, now let's look at denominator. X plus 3 is equal 0. X is equal negative 3. Another critical point, because we get at point x is equal negative 3, we get division by 0. So we have two critical points in this case. So let me build on the line of numbers. So where is our 1 and negative 3? Let's assume this is our 1, and let's assume this is our negative 3. So this 1 and negative 3 is breaking down the line of numbers into 3 intervals. First interval is here, which is between negative infinity and negative 3. Okay. Second interval between negative 3 and negative 1. And third interval between 1 and infinity. Okay, now let's identify the sign of this inequality, okay, on each interval to figure out what which interval is gonna be the solution. Okay, so we're going to take some testing number from first interval, second interval, and third interval. So we know that this rational inequality is supposed to be less equal 0. So we are going to, the bottom line is we are going to take testing points in each of these 3 intervals, and if it brings us to less or equal 0, then we take that interval as a solution. But if it brings us to opposite, which means in this case will be greater than 0, then that interval cannot represent the solution. Okay, and then we will explore critical points. So first thing, let's take the point on interval negative infinity and negative 3. Okay, let me take negative 4. Okay, I'm going to take negative 4. Here, negative 3 and negative positive 1, positive 1. I'm going to take obviously 0, the easiest case, and between 1 and infinity, I'm taking 2. Okay, let's see what we get. So negative 4 for the first one, we are doing for first interval, negative 4 minus 1, and then negative 4 plus 3. Here we get negative 5. Here will be negative 1, and that gives us positive 5, which is greater than 0. So this interval, it does not satisfy. It's positive. Next, let me see. 0. I'm taking 0 between -3 and 1. So 0 minus 1, 0 plus 3, I'm getting -1/3, which is less than 0. Bingo, this interval satisfies, it's negative, and I have there negative. And lastly, between 1 and positive infinity, I'm getting 2. So 2 minus 1, oops, 2 minus 1 and 2 plus 3. And let's see what we get. It's gonna get, it's +1, +5, which is gonna be greater than 0. And that means it's not gonna satisfy. Also, let's check critical points, 1 and -3. So x is equal 1. So 1 minus 1 and 1 plus 3. It's going to be 0/4, which is going to be 0. And it's satisfying the condition less or equal, right? So it's equal 0. So this going to work as an answer. Yes? So, and x is equal -3 cannot be satisfying because I'm getting -3 plus 3, denominator will be 0. X cannot be equal 3 because of division by 0. Okay, so practically what is it going to be? The solution is going to be the our interval that is between -3 and +1. Okay, let's do one more. We have 4x over x minus 6. 4x over x minus 6 is less than 1. Okay, what do we have? Let's find critical points. So to find critical points, I'm going to bring this one on the left side. 4x over x minus 6 minus 1 less than 0. Right? Bring to common denominator. Common denominator is going to be x minus 6, which means here divide by x minus 6. Here we multiply by x minus 6. With 0, I don't have to do anything because it's going to be 0. And practically, I'm getting 4x, x minus 6, minus x minus 6 over x minus 6 less than 0. Keep in mind that when we have dealing with inequality, we cannot drop any denominator. We are going to keep the denominator only when you are solving linear rational equation. Okay, so common denominator x minus 6. Therefore, we are getting x minus 6 for x minus x plus 6 less than 0. Remember I mentioned in the video where I solved the rational equations that negative sign in front of fraction we treat as a negative sign in front of parentheses. So therefore I flipped the sign. X was negative, became positive, became negative. 6 was negative, became positive. And we are getting 3x plus 6 over x minus 6 is less than 0. Okay, now once we have this, let's identify a critical point. Okay, this in numerator I can take 3 out. It will be x plus 2, x minus 6, less than 0. So one point is going to be x plus 2 is equal 0, x is equal negative 2, okay? And the other point, x minus 6 is equal 0, and x is equal positive 6. So let's see, x cannot be equal positive 6 because when x is equal positive 6, the denominator becomes 0. So we cannot divide by 0. It cannot happen. And when x is equal negative 2, so we look here, right? X is equal negative 2. So numerator become 0, and the answer is 0, which also does not satisfy because cannot be equal 0. It says only less than 0. Okay, at this point, so let's look between critical points, what's gonna happen. Let me take this line of numbers. Okay, this is our negative 2. This is our positive 6. Let me take here. All right, so negative 2, positive 6. Let's say less than, from negative infinity to up to negative 2. Here is interval from negative 2 to 6. And then here is interval from 6 to positive infinity. Okay, so in this case I'm taking negative 3. X is equal negative 3 in this interval, negative infinity, negative 2. So if I plug, and I'm going to plug to here, okay? I'm going to plug to the simplified fraction. And we have, well, 3 times, oops, 3 times negative 3 plus 2 and 2 negative 3 minus 6. So we are getting here negative 3, negative 1, and negative 3. Here is negative 9, which is getting positive, right? Positive 1/3, which is greater than 0. But we need less than 0, right? This is plus. Okay, so this one is not gonna work. Next one, we have between negative 2 and 6. Okay, taking 0. X is equal 0. All right, if I plug 0, then 3 times 0 plus 2 over 0 minus 6. It's going to be 2 times 3 is 6, and dividing negative 6 equal negative 1. This is satisfies less than 0, so the answer is going to be acceptable because it's negative. And lastly, we'll take between 6 and infinity. So I'm taking x is equal how much? 7. So it's going to be 3 times 7 plus 2, and then 7 minus 6. It's going to be positive, right? 9 times 3, 27. And this is 1, which is greater than 0. And the positive does not satisfy because it has to be less than 0. So from here, the interval is going to be between negative 2 and 6. And the solution is going to be negative 2 and 6. Okay, and let me solve one more. Let me combine this. Okay, And I will solve, let me see. I'll do this one also. Okay, and I will solve another interesting problem. 5 over, what do we have here? X squared minus 2x minus 15, and that is greater than 0. Okay, so, well, we have the quadratic expression, right? Trinomial. Let me see if I can factor it down. It's going to be x plus 3 and x minus 5, right? So it's, if I rewrite it, 5 over x plus 3 over x minus 5. And this is supposed to be greater than 0. Okay, let's find critical point. So x plus 3 times x minus 5 is equal 0, right? That's going to be critical point because its denominator become 0. So what's going to happen at x is equal negative 3 and or x is equal positive 5, those become critical point, but they cannot be in the solution because at the point of negative 3 or positive 5, it becomes, denominator becomes 0. So this cannot be the solution, this critical point. Okay, but let's see in between critical points what's going to happen. So this is negative 3. This is positive 5. Okay, so let's see. Taking between negative infinity and negative 3. Here we have between negative 3 and 5 and positive infinity. Okay, taking number negative 4, x is equal negative 4. What do we have? 5 over negative 4 plus 3, negative 4 minus 5, and we are getting, here is negative 1, here is negative 9. We are getting positive 5 over positive 9, which is greater than 0, and it does satisfy, right? So we are getting here positive and also doing positive check mark. So this is goes to the answer, meaning this one. Let me write, this is better. This range is going to the solution. Well, okay, that doesn't matter where I mark down because it's in this interval. Okay, next one. Between negative 3 and 5, obviously I'm taking my favorite 0 because it makes my life easier. And it's going to be 5 times 0 plus 3 and 0 minus 5. And we are getting here negative 15. Here is 5. We are getting, I don't even need to simplify because it's less than 0, which will not satisfy because we need greater than 0. And lastly, 5 and infinity, I'm taking x is equal positive 6. 5 over 6 plus 3, 6 minus 5. And we are getting 5 over 9 times 1, it's going to be positive, right? If it's positive greater than 0, then it's moving in the answer. So the solution is going to be here. So negative infinity, negative 3, or 5 and infinity, right? Because the 6 that we have green check mark is in the area, in the interval 5 and infinity, and x is equal -4, which also the green mark, it's in the interval -infinity, -3. Okay, and lastly, let me solve another one, last one, and that would be plenty. I looked into every case. So we have 1/3 minus 2 over x squared, and it's less than 3 over 3x. Okay, so solution. First thing we are going to do, bring to common denominator. So common denominator, we have 3 and x squared. Common denominator is going to be 3x squared, which means, let me here rewrite separate, not to scratch on original problem. Oh, okay, it's supposed to be 5. Hold on, I'm looking, why is it 3 and 3? How does it make sense? Original has 3 and 3, numerator, denominator. Okay, less than 5 over 3x. So common denominator 3x squared, which means here we multiply by x squared, here multiply x squared, here we multiply by 3, and here we multiply by x and x. And we are getting 3x squared, it's going to be x squared minus 6, moving over, minus 5x. Less than 0. Okay, and what do we get here? I'm going to FOIL it, because x squared minus 5x minus 6, I can break it down as an x minus 6 and x plus 1. Okay, over 3x squared, less than 0. All right, so what are our critical points? Our critical points are x is equal, positive 6, yeah, because it becomes 0, or x is equal -1 in numerator, become 0, and x is equal 0 for denominator. Okay, so 6, -1, and 0. So x is equal 0, up front we can say it does not satisfy, because we get division by 0. But 6 and -1, we'll see. We are going to test it out. So 1, 2, 3 critical points this time, which means we are going to test 4 intervals. So -1, here is going to be 0, and here is going to be 6. All right, so in this area we are getting -infinity to -1. Here we are getting -1 to 0. Here taking 0 and 6, and 6 and positive infinity. Okay, equal sign is missing there. It's only less than. We have to get less than 0. All right, so I'm taking between -infinity, -1, so taking x is equal -2. So which means it's going to be -2 minus 6, -2 plus 1, over 3 times -2 squared. Okay, we are getting -8 times -1 divided by 412. So we are getting negative number, right? No, positive actually. -8 times -1 is positive. So 8 over 12, I don't care about simplification. It's going to be positive, which means it's falling out, because we need the less than. So this is going to be positive. Okay. What else we have? Between -1 and 0, Oh God, we need to take what? Negative 0.5, huh? Okay. So negative 0.5 minus 6, negative 0.5 plus 1, and the 3 times negative 0.5 squared. So what do we get here? This is going to be negative 6.5 and times here negative 0.5, I mean positive 0.5 over 3 times 0.25. So here we are getting negative, here we are getting positive. So result is negative, and it's gonna fit to requirement of inequality. So this is gonna be negative. And lastly, I'm going to check between 0 and 6. X is equal 3, for example. All right, 1, 2, 3, okay. So, and it's going to be 3 minus 6, 3 plus 1, and then 3 times 3 squared. Okay, so it's going to be negative here, negative 3 times positive 4, and here is positive 927. So it's going to be negative over positive, which is less than 0, and bingo, that's satisfy. So it's going to be here negative. And lastly, we are checking between 6 and infinity, which is going to take, let's say, 7. Okay, so if we take 7, we get 7 minus 6, 7 plus 1, and then 3 times 7 squared equal 1 times 8. So 7 squared 49, and whatever it is, it's positive. So we are getting here positive over positive, which is greater than 0, and red color deserve because it doesn't satisfy, so it's going to be positive. So from here, we are going to get between the solution is going to be negative 1 comma 0, okay, and 0 and 6 intervals, okay. And x cannot happen, x is not going to satisfy. And let's check negative 1 itself. If it's negative 1, it's going to work. If I take negative 1, so what's going to happen? Negative 1 minus negative 6, and then negative 1 plus 1. Okay, it's going to get 0. That's it. Negative 1 also cannot satisfy here, right? Because there is no equal sign. It has to be less than 0. But we are getting, with negative 1, we are getting equals 0. So it doesn't satisfy. The same way is with 6. It's becoming equal 0. So this critical point do not satisfy, and it's going to be between critical points, excluding critical points. All right, I'm done, and see you in next video.